In this video, we'll prep for finding the inverse of functions. Now, when you're finding the inverse of functions, one of the things you're going to have to do is to solve a function for a specified variable. So that'll be like back in the days when you're in maybe an intermediate algebra course where you're to solve a formula for a specified variable. Like maybe when you had the function that converts from, let's say, Celsius to Fahrenheit, but you wanted to go the other way, so you would solve that formula for Fahrenheit, so for the F, and get everything else onto the other side. So it's going to be very similar for that when you're finding the inverse of a function. So let's look at some examples of solving functions for a specified variable, or solving equations for a specified variable. So in this case, okay, so we have to solve the formula y equals to 2x plus 7 for x. So what we want to do for the final answer for this problem, the way it's written right now, is to get x by itself on one side, everything else onto the other side. So what I would do, let's see, so we have y equal to 2x plus 7. So the only x in this case is when we have that 2x term. So what I'm going to do is to get that 2x term by itself first, so I'm going to subtract 7 from both sides of the equation. So we get y minus 7 equals to 2x. Now we want to get this x by itself. So what you could do is divide both sides by 2. So x would equal to y minus 7 all over 2. Now another way you could write this is divide each term in the numerator by 2. So we get y over 2, so that'll be 1/2 y minus 7 divided by 2, so minus 7/2. So that would be another way you could write that formula that's now solved for x. And I'll talk about at the end of this video why are we doing this. Now another example is, let's say if we have the formula y equal to x plus 1, all of that divided by x minus 2. And what we want to do is to solve this formula for x. So we want to get everything with x on one side, everything else onto the other side. Now we do have two x's. We have the x in the numerator, x in the denominator. What we first want to do is to get rid of the fraction by multiplying both sides by the LCD, which in this case is just the x minus 2. So I'm going to multiply both sides of the equation by x minus 2. So let me write that. So we'd have the x minus 2 times the y on the left-hand side. And then the right-hand side, the x plus 1 over x minus 2, we're going to multiply that by x minus 2. So on the right-hand side, the x minus 2's would cancel, so you would just have x plus 1 on the right. Now on the left-hand side, you'd have that x minus 2 times y. What I'm going to do with that is I'm also going to distribute that y because we're going to solve for x. So we got to get all the x's out. We don't want them inside the parentheses as well. So we distribute the y, so we get xy minus 2y. So right now we have the formula xy minus 2y equals to x plus 1. So again, we're trying to solve for x. That means we want to get everything with x on one side, everything else onto the other side. So I'm going to subtract this x from both sides of the equation, get everything with x onto the left-hand side. And I want to get this 2y term onto the other side, so I'm going to add 2y to both sides. So on the left-hand side, so the minus 2y plus 2y, those cancel, so we'd have xy minus x. And then let's see, that x minus x, those cancel, so we would have 2y plus 1 on the right-hand side. Now we do have everything with x on one side, but we want everything else onto the other side. So we don't want this y here and this minus sign. We just want, in the end, we just want x equals everything else onto the other side. So what you might notice though is everything on the left-hand side does have an x in it, so we could factor out the x. So we'd have x times y minus 1 equals to 2y plus 1. And now to get this x by itself, we want to get the y minus 1 onto the other side. So we have x times y minus 1. So what we're going to do is divide both sides by the y minus 1. So we'd have x equals to the 2y plus 1 all over the y minus 1. So we now solved that formula for x. Let's look at a couple more examples of this. Let's say if you're to solve the formula y equal to 2 times the cube root of x minus 9 plus 3, and you want to solve this one for x. So we want to get this x here by itself on one side, everything else onto the other side. So one thing you want to do first is, let's see, so this whole term with the radical, that has the x. So we want to get that term by itself. So let's subtract 3 from both sides of the equation. So we'd have y minus 3 equals to 2 times the cube root of x minus 9. Now, the x is underneath this cube root, so we have this 2 times that cube root. So to get that 2 onto the other side, what we're going to do is divide both sides by 2. So we'd have y minus 3 all over 2 equals to the cube root of x minus 9. So what we would next want to do is the x is underneath this cube root. So what we would want to do next is to get rid of the cube root by cubing both sides. So we're going to cube both sides of the equation, so that on the right hand side, when you cube the cube root, you'll just have what's underneath the radical. So you'll just have that x minus 9. And then on the left hand side, let's just leave that as y minus 3 all over 2 cubed. Because now we're almost done, because once again we're trying to solve for x, so we're trying to get the x by itself on one side. So we have x minus 9 on the right hand side. So to get that x term by itself, let's just add 9 to both sides of the equation. So we'd have x equals this y minus 3, all of that divided by 2, all of that cubed, plus 9. So we've now solved that formula for x. Now let's look at another example. And this one will be a special example, which you'll see. So we're to solve the formula y equal to x squared plus 4x minus 3. We're to solve it for x. So one thing, what we're going to do is to use the method of completing the square. So we're going to get all the terms with x on one side, everything else on the other side, which in this case just means we're going to add 3 to both sides of the equation. So we'll have y plus 3 equals to that x squared plus 4x. Now we use the method of completing the square. So we want what's on the right hand side to be a perfect square trinomial. So we take the number in front of the x, because there is no number in front of our x squared. So we take that number in front of the x, which is 4, divide that by 2, which would be 4 divided by 2 would be 2, square that, which is 4, and add that to both sides of the equation. So we're going to add 4 to both sides of the equation. Now the reason why we did that is now what's on the right side, the x squared plus 4x plus 4, this is a perfect square trinomial because it factors to x plus 2 times x plus 2, or same thing as x plus 2 squared. Now on the left hand side we had y plus 3 plus 4. Combining our like terms, the 3 plus 4, that'll give us y plus 7. Now we want to get the x by itself, but it's inside the parentheses for right now. So what we're going to do is to square both sides, or not square both sides. We're going to take the square root of both sides. Now one thing you got to remember is when you were solving quadratic equations using the square root property, that if you take the square root of both sides, do not forget you'd have that plus or minus that square root of y plus 7. So we have the plus or minus the square root of y plus 7 equals to, now the square root of x plus 2 squared, that would just be x plus 2. And now to do the last step to solve for x, to get the x by itself, we're going to subtract 2 from both sides. So on the right side we just have x. Now subtracting 2, that's the same thing as adding a negative 2. So I'm going to write this as negative 2 plus or minus square root of y plus 7. So like I said, this is a special case because you do have that plus or minus in the formula. But this will come up when you're finding the inverses of functions where the function as it is written originally may not have an inverse, because there'll be certain rules for finding the inverse, which you'll see in the college algebra class. And that'll help let you decide, okay, is it going to be the plus or is it going to be the minus for that square root? Now, one last thing, a little preview of why did we talk about all this stuff when we're talking about solving for the inverse of a function. That, let's say for that first one, when we solve for x, what you would do next for the steps that you'll see in the college algebra class when you're finding the inverse of this function, y equal to 2x plus 7, so this linear function, that you'll solve that formula for x, switch the x's and y's, so this will be now, instead of x equals to 1/2 y minus 7/2, that'll be y equals to 1/2 x minus 7/2. And what it'll turn out is that'll be the inverse of that original function. Just as when we did this for this rational function, that when we solve for x, the next step what we would do is switch the x's and y's. So this will be y equals to 2x plus 1 over x minus 1. And what it'll turn out, that'll be the inverse of that original function. And similarly for the next one as well.